I'm going to use elimination to solve this system of linear equations. Elimination involves adding both of the equations together and having one of the variables eliminated as a result. Here I can see that if I were to add both of these equations together, these x's would cancel each other out because I have a positive 2x and a minus 2x. Now what is going to allow me to add these together is the fact that these two sides are equivalent. Minus 2x plus y is equal to 9. So this left side is effectively equal to 9. So if I were to add this bottom equation to this top equation, it would be as if I was adding 9 to both sides, which I can do with equations, assuming that I add equal amounts to both sides of the equation or do the same modification to both sides of an equation. It is alright if I do that because the equality will still be maintained. For an equation I could add 1 to both sides or 2 to both sides or subtract 3 to both sides, multiply both sides by 2, divide both sides by 2. So it is therefore perfectly okay for me to add these two equations together because this side is equal to this side. And when I add both of these together, I'm essentially adding, if I was to add this bottom equation to this top equation, I would essentially be adding 9 to both sides. So when I add these equations together, I get minus 4y is equal to 12. I solve for y is equal to minus 3. And now I use the same procedure that I did when using substitution. I take this y and I substitute it back into one of these two equations. It does not matter which one it is. I will use the second one. Minus 2x plus minus 3 is equal to 9. X is equal to minus 6. So the solution for this system of linear equations is minus 6 minus 3. That was a very simple one where the elimination was readily apparent. However, most of the time, it will not be so. For this next example, it will take some modification of the existing equations for the elimination to become apparent. For this one, I'm going to do 2x plus 3y is equal to 21. 3x minus 4y is equal to 23. And I want to know the solution to this system of linear equations by using the elimination method. Here it is not immediately apparent how the elimination is going to work. However, using the principle that if I modify both sides of the equation, it is still equal to the same thing. What I can do is multiply these equations by whatever amount I need in order to get either of these terms, either the x's or the y's, to be able to cancel out the other one. Here I have a minus 4y and a positive 3y, so it is a good candidate. If I were to multiply this top equation by 4, this would become a 12y. If I were to multiply this bottom equation by 3, it would become a minus 12y. So if I were to multiply the top by 4 and the bottom by 3, the y's would drop out of the equation, leaving me with only x's, in which I could solve for very easily. Also, what I could do is do it for the x's as well. While they are both positive right now, there's nothing that says that I cannot either subtract the equations, which is perfectly fine, or simply multiply by a negative number and then add them. So here I can multiply the top by 3 and get 6x, and 3 times everything else. And here I can multiply it by minus 2, in which case I would have a minus 6 here. And then I would be able to add them together and the x's would be eliminated. But for now, I think I will simply multiply the top by 4 and the bottom by 3, although it would make more sense to multiply out the x's because I would multiply by smaller numbers. However, for simplicity's sake, in case I forgot, I'm going to do the more obvious way, and then as I work through problems, I will become reacquainted with it. If I multiply this top by 4, I'm going to get 2x plus, well, I forgot to multiply, but 8x plus 12y is equal to 84. And this bottom one will be 9x minus 12y is equal to 69. Now, adding both of these equations together will cause the y's to be eliminated from the equation, leaving me with a single variable, which would be 17x. Y's are eliminated is equal to 153. And 153, 10 times 17 is 117, minus 17 is 153, so that would be 9. So if I were to divide both sides by 17, x is equal to positive 9. Now that I have this 9, I substitute it back into either one of these equations. I will use the top equation since the x is lower. 2 times 9 plus 3y is equal to 21. 18 plus 3y is equal to 21. 3y is equal to 3. Y is equal to 1. The solution for this system of linear equations is 9, 1. And both of these happen to have solutions. However, in the case of parallel lines, and in the case where both lines are the same things that happened for elimination, where both variables will be eliminated, will happen for the elimination. When I make the variables equal, go to make the variables equal, both the x's and the y's will cancel out in the case of there being parallel lines and two lines being the same. And in the case of parallel lines or two lines being the same, in the substitution, we had a case where parallel lines we had an untrue statement, and in the case of two superimposed lines, a true statement. The same thing applies in this method. If both variables are eliminated and I am left with a true statement, then there are two superimposed lines. If both variables are eliminated and I have an untrue statement, then there are parallel lines.